Okay, so in this video, we're going to be talking about how to solve exponential equations. Now, in order to do this video, you have to have knowledge in properties of logarithms. You also have to have knowledge in properties of exponents. I have videos on both of those topics. I'll go ahead and link them below. That way you have access to that content. But assuming you have knowledge in those topics, let's talk about how we're going to solve these equations. So I have 6 problems here, and technically on the first 3 problems, you don't even need to use properties of logarithms, okay? But on the last 3 problems, you will have to use properties of logarithms, so just keep that in mind. So whenever you have an exponential equation and you're looking at your base, you want to try to match the bases, because if you can do that, they will cancel out. So for example, I have a base here of 125 and a base here of 25. Can I match those bases? Can I make them the same? Well, I could, because this 125, I know that I could rewrite as 5 to the 3rd power. And this 25, I could rewrite as 5 to the 2nd power. So for example, I could rewrite this whole equation as 5 to the 3rd power, and then times my exponent value here, which is negative 2x minus 1. So times negative 2x minus 1. Equal to, well, I can rewrite 25 as 5 squared, okay? If you can do that, the bases will cancel out. So for example, this will cancel and this will cancel, and now all I have to do is solve my equation, which is right here, this part and this part. Now, I'm going to show you why that works out. It's really simple, and essentially it goes back to properties of logarithms. So think about the power property when you're dealing with logarithms. If you have log, and then base x, and then raised to some power, I'll just say y here, okay? I can bring this y down to the front based on the power property of logarithms. So technically, I could rewrite this whole problem as y and then log base x, okay? So we can use that knowledge on this problem that we're doing here. So for example, what you're technically doing, okay, when you're canceling out these bases, you're taking the log on both sides. So for example, if I take log on this side and log on this side, I can bring down these exponential values, okay? And when I do that, I get the following. I'll get 3, then times negative 2x minus 1, and then log 5, equal to, bring down the 2, and then I get log 5. So essentially what's going to happen here, you can see that I have log 5 here and log 5 here on both the left-hand side and the right-hand side of the equal sign. They will just naturally cancel out, and you're going to be left with what we have up here, this 3 times negative 2x minus 1 equal to 2. But you don't have to remember that. All you have to remember is match up the bases and they will cancel out. But this is why it happens, okay? So technically you're utilizing properties of logs here, but again, you don't have to remember that, just match up the bases, okay? So let's go ahead and solve it now. So let's get rid of all of this here, and we're gonna solve the equation. We talked about how the bases will cancel, and now we're gonna be left with 3 times negative 2x minus 1 equal to 2. And now all we have to do is solve. So I'll go ahead and distribute the 3. I get negative 6x and then minus 3. Equal to 2. I have to add 3, and then I have to divide by a negative 6. If I do that, I get x is equal to, adding 3, I get 5, right? 2 plus 3. And then I have to divide by a negative 6. So dividing by a negative 6, there we go. There's my final answer, okay? So x is equal to negative 5 all over 6. All right, let's go ahead and try another example. So here's our next example. You can see we're dealing with another exponential equation. And again, let's try to match up the bases. Now, this one's not as obvious because you have 1 over 625. But remember, 5 to the 4th power is 625. So let me go ahead and rewrite this as 5 to the 2x, okay, equal to 1 over 5 to the 4th power. Okay, that's 625. Now, how can I bring up this value, this 5 to the 4th power? Well, remember your negative exponent properties. If I have x to the negative n, I can rewrite that as 1 over x to the n. And you can go back and forth here. So if I have 1 over x to the n, I can write it as x to the negative n. So picture this 5 as my x, this 4 as my n. To get it in this format here, I'm just going to make the exponent negative. So for example, I'm going to rewrite it as 5 to the 2x equal to 5 to the negative 4. Okay, it's the same thing. Now the bases will cancel, and I'm left with 2x equal to negative 4. All I have to do here is divide by 2, and I'm done. So x is going to be equal to negative 2, right? Negative 4 divided by 2, we get negative 2. All right, let's try another example. So here's our next example. Same thing, we're dealing with exponentials here. Can we match up the bases? Well, this 216, that's really 6 to the third power. So I can rewrite this as 6, and then to the third power, and then it's going to be 3 times x. So 3 times x, right? Like that. Equal to, this 36 I can rewrite as 6 squared. So 6 to the second power, and then times a negative 2x. My bases will cancel out here. So cancel, cancel, I'm left with 3x equal to negative 4x, right? When I multiply there. And so from here, what do we end up getting? Well, how do I solve for x? Well, let me go ahead and add this 4x on both sides to see what will happen, okay? This will cancel, I get 7x equal to 0, and then I have to divide by 7, so 0 divided by anything is 0. I get x is equal to 0, okay? That's my answer there. All right, let's try some more examples. This time, though, you're not going to be able to change the base. You're going to have to use properties of logarithms. So here's our next example, and this one is definitely different. Notice how you're not going to be able to change the base here, okay? So whenever you have a problem like this, the goal is to isolate the exponential. So I want to isolate this part here before I do anything. That's my goal. So my first step, I have to minus 7. So if I minus 7, I'm going to do 9 minus 7, I'll get 2. So rewriting the equation, I'll get 14 to the power of 9x equal to 2, okay? So again, it's clear I cannot rewrite this with the same base. That is not going to work here. So how can I solve for x? Well, remember properties of logarithms. Remember the power rule. If you have log, and then base, and then x, and then again, if you have some power y, I can bring down that exponent based on the power rule. So this y can come down to the front. So we can use this to our advantage. How can I bring down this 9x to the front? Well, in order for that to happen, I'll have to take a log on both sides to balance out the equation. Because if I have a log here, I'll be able to bring down that exponent. Okay, so for example, I'm going to bring down the exponent. I have 9x. But in order for me to do that, I must have a log there. So log, and then of 14, equal to, now you have to balance it out. So what I do to one side, I have to do it to the other side. I have to take log of 2 here. So log of 2. And now from here, all you have to do is solve for x. So I'm going to divide both sides by log 14. Okay. And so from here, you can go ahead and divide this out in your calculator. You're going to get a decimal value. But to maintain accuracy, I'm actually going to leave it as log 2 over log 14. That way I'm not rounding and I get the most accurate answer. All right. So technically what I have now is 9x equal to log 2 all over log 14. So my last step, I have to divide both sides by 9. Now remember, keep, change, flip. Okay, that's technically what's going to happen here. I'm going to do log 2 all over log 14. And then I have to divide it by 9. So divide by 9, which is really over 1. So if you remember, keep, change, flip, I keep the first fraction right here, this log 2 over log 14. I change my sign to multiplication, and then I flip. So it becomes 1 over 9. So your final answer when you do that is going to be x equal to log 2 all over, again, if you keep, change, flip, you get 9 log 14. Okay, just like that. Okay, so you can always write out keep, change, flip to make it a little more obvious, but that's going to be your final answer. And again, that is going to give you the most accurate answer because you're not rounding. Okay, so we're going to leave it like that in terms of log. All right, let's try another example. So here's my next example. Again, I cannot match up the base yet. Okay, I might be able to in this problem, just looking at it. Okay, but your first step here is you want to isolate the base and the exponent. So I have to get rid of this 4. And this 4 is being multiplied. So the opposite of multiplication is division. I'm going to divide both sides by 4. Okay, that will cancel out here. And 12 divided by 4 will give me 3. So now I have 9 to the power of x minus 2 equal to 3. Now, you could go ahead and take log on both sides to bring down this exponent value. That's fine. You could do that. You're going to get the right answer if you do that. But this one, at this point in time, I can now match up the bases because I have a 9 here as a base and a 3 here. So technically what I can do, I can rewrite this 9 as 3 to the second power, and then my bases will match up. Okay, so for example, I can rewrite it as 3 to the second power, that's my 9, and then I have to multiply it by x minus 2. So times x minus 2, okay, equal to 3. Now really this 3 has an exponent of 1. So I'm going to go ahead and write that in, that way we can see it. So now the 3's will cancel, okay, and I'm going to be left with 2 times x minus 2, okay, equal to 1. Now all I have to do is solve for x, okay? I get 2x minus 4 equal to 1. Okay, now I have to add 4 and divide by 2. So adding 4, I'll do 1 plus 4, I get 5. And then divide by 2, I get 5 over 2. So my final answer here is going to be x is equal to 5 all over 2. Okay, and this problem is done. All right, so this one we actually did not have to use properties of logs, but you could have. If you use properties of logs at this point right here, you still would have gotten the same answer, okay? So just keep that in mind. All right, let's go ahead and try one more example. Okay, so here's my last example. Notice that I cannot match up the bases here, meaning I want to isolate the base and the exponent right here. Okay, so I have to minus 9 on both sides. That's going to give me 20 to the negative x equal to 70. Okay, so what do we do from here? Well, again, I cannot match up my bases. I can't use that technique. I'm going to have to take log on both sides so that I can bring down this negative x, okay? So doing that, I bring down the negative x, and then I'll have log of 20, okay? Remember, I have to balance it out. So on this side here, I'm going to have log of 70. Okay, a couple more steps, and then you're done. You're going to divide both sides by log 20. Okay, this will cancel, and we'll write it like that. Now again, you could plug this into your calculator, you could get the decimal value, but I'm going to leave it as log 70 over log 20. That way I'm maintaining accuracy, right, and I'm not rounding. So now I have negative x equal to log 70, okay, all over log 20, and you're pretty much done at this point. You can't leave this negative here though. So you're going to have to divide both sides by -1 to get rid of that. And that's just going to make your answer negative. So your final answer is going to be x is equal to negative log of 70 all over log 20. Okay, just like that. And this problem is now complete. Okay, so that is how you solve equations dealing with exponentials. It's pretty straightforward. A couple different techniques you can use. You can try to match up the bases of the problem. That would be the easiest route, but sometimes you can't do that, and you're going to have to utilize properties of logarithms, and in particular, the power property, okay? So just keep that in mind, and that's pretty much it. So if you gained anything from the video, or if the video helped you in any way, if you could just go ahead and give it a thumbs up, that would be greatly appreciated. Also, make sure you subscribe to the channel. That way you get more math videos in the future, and I'll see you in the next one.